12,000 years ago, someone dug a mine in one of the driest places on Earth. Not a shallow scrape in the dirt, a deliberate, organized excavation, with specialized tools, discarded waste rock, and repeated visits over centuries. The miners were not part of any civilization we would recognize. They had no cities, no writing, no metal. They were coastal hunters and fishers who, for reasons we can only partially reconstruct, walked inland into the Atacama Desert and began extracting red pigment from the rock. That mine is now the oldest reliably documented mining operation anywhere in the Americas, and it is only the beginning. Today we are crossing one of the most desolate landscapes on the planet, a place where some weather stations have never recorded a single drop of rain, where the soil has been compared to the surface of Mars, and where NASA tests its instruments because nothing else on Earth comes close to that level of sterility. And yet, beneath and across that emptiness, researchers have found things that do not fit comfortably into the story most of us were told. 12,000-year-old miners. Evidence of human life in the hyper-arid core of the desert nearly 13 millennia ago. Hundreds of enormous images carved into hillsides to guide travelers along routes that no longer exist. Vast fields of melted glass whose origin is still genuinely debated by scientists. Prehistoric hunting systems so large they can only be understood from space, and one of the strangest human skeletons ever subjected to modern genetic analysis. 6 discoveries, 1 desert, and a very different picture of what people were doing here long before anyone thought to look. Let us start underground. The town of Taltal sits on the coast of northern Chile, pressed between the Pacific Ocean and one of the most barren stretches of land on the continent. For most of its modern history, Taltal was known for nitrate mining and fishing. It was not the kind of place anyone expected to rewrite the early history of mining in the Western Hemisphere. But a few kilometers inland from the coast, archaeologists identified a site they designated San Ramon 15. What they found there was not a cave where ancient people occasionally picked up pieces of colored rock. It was a mine, a real one. The distinction matters. Across the ancient world, prehistoric people collected natural pigments from exposed surfaces. That is common and well documented. What happened at San Ramon 15 was qualitatively different. Excavations revealed areas where rock had been deliberately broken and removed. There were accumulations of mining debris, the kind of shattered, discarded material that forms when someone is systematically working a deposit rather than casually gathering loose fragments. And there were stone tools specifically suited to the work, implements shaped for pounding, prying, and processing mineral-bearing rock. Radiocarbon dating placed the earliest mining activity at approximately 12,000 to 10,500 years ago. To put that in perspective, this was the late Pleistocene, the tail end of the last ice age. Humans had been in South America for only a few thousand years, possibly less. The great civilizations of the Andes, Tiwanaku, the Inca, the Moche, were 10,000 years in the future. The people working this mine were among the earliest inhabitants of the continent. What were they after? Iron oxide. Specifically, iron-rich red pigments, the kind of material often grouped loosely under the label red ochre. This is one of the most ancient and widespread materials in the entire human archaeological record. In Africa, Europe, and Australia, red ochre appears at sites tens of thousands of years older than San Ramon 15. Its uses were varied and, in many cases, still debated. At some prehistoric sites, red ochre is clearly associated with burials and ritual activity, suggesting symbolic or ceremonial importance. At others, traces appear on tools, hides, and surfaces in ways that suggest practical applications, processing animal skins, protecting materials from insects or decay, or even as a component in adhesives for hafting stone tools to wooden handles. Body painting and personal decoration are another possibility, supported by ethnographic evidence from cultures around the world that continued using iron-rich pigments well into the historical period. At San Ramon 15 itself, the direct archaeological evidence tells us what was being extracted, but it does not provide a complete picture of exactly how the pigment was ultimately used. What we can say is that the material was valuable enough to justify repeated, organized visits to the site. These were not one-time collecting trips. The archaeological layers indicate activity spanning centuries, possibly longer. And that is what makes the site genuinely important. The people who operated this mine belonged to early hunter-gatherer and coastal fishing communities. In traditional models of early South American settlement, these groups are described, correctly, as mobile populations who followed seasonal resources along the coast and into nearby inland areas. They hunted marine mammals, gathered shellfish, fished, and exploited whatever the landscape offered. What San Ramon 15 adds to that picture is a level of planning and specialization that goes beyond opportunistic foraging. These communities identified a specific geological deposit. They recognized its value. They returned to it repeatedly. They developed tools suited to extracting it. And they did all of this 12,000 years ago, making San Ramon 15 the earliest reliably documented mining operation in the Americas. The word reliably is important here. There are other sites across the Americas where early people clearly used mineral pigments, and some of those sites are very old. But the combination of clear evidence for deliberate underground extraction, specialized toolkits, accumulated mining waste, and secure radiocarbon dates makes San Ramon 15 the strongest case for actual mining, as opposed to surface collection, at such an early date on the continent. It rewrites one small but significant paragraph in the story of early South American peoples. They were not merely surviving on the edge of the desert. At least some of them were already reshaping the underground landscape to get what they needed. And if that seems early for mining, consider what archaeologists found deeper in the desert itself. Quebrada Mani is not the kind of place that invites human settlement. It sits in the hyper-arid core of the Atacama, in the Pampa del Tamarugal region, a landscape so dry and so lifeless that it has been used as an analog for the surface of Mars. Annual rainfall in some parts of this zone is effectively zero. The ground is crusted with salt. Vegetation is absent or reduced to scattered patches near the rare spots where subsurface water reaches the surface. If you were asked to name the last place in South America where you would expect to find evidence of Ice Age human occupation, this would be a reasonable answer. And yet, when archaeologists excavated Quebrada Mani, they found exactly that. The site produced stone tools, fragments of worked wood, plant fibers, pigments, evidence of controlled fire, and, most intriguingly, marine shells. The radiocarbon dates place the occupation at approximately 12,800 to 11,700 years ago, firmly in the late Pleistocene. How do we know those dates are reliable? Radiocarbon dating measures the decay of carbon-14, a naturally occurring radioactive isotope absorbed by living organisms during their lifetimes. When an organism dies, the carbon-14 begins to decay at a known rate. By measuring how much remains in a sample of organic material, such as charcoal from a hearth, a fragment of wood, or a piece of shell, researchers can calculate how long ago that organism died. The technique is well established and, when properly calibrated, reliable for materials up to roughly 50,000 years old. At Quebrada Mani, multiple samples from different materials converged on the same date range, strengthening the confidence in the chronology. The preservation conditions of the Atacama are part of what makes the site so valuable to science. In wetter environments, organic materials like wood, plant fibers, and even bone degrade rapidly. Bacteria, fungi, insects, and moisture break them down within decades or centuries. In the Atacama, the near-total absence of moisture halts most biological decomposition. Materials that would vanish in a tropical forest or a temperate grassland can survive for thousands of years in the desert with remarkably little degradation. This is why the Atacama has become one of the most important archaeological preservation environments on the planet. It keeps things that other places destroy. Now, about those marine shells. Quebrada Mani lies roughly 70 kilometers or more from the Pacific coast. Shells from marine species do not appear in the middle of a hyper-arid desert on their own. They were carried there by people. This immediately tells us something important about the communities using this site. They were not isolated groups trapped in one ecological zone. They were moving between the coast and the interior, or they were connected through exchange networks with coastal populations, or both. Either way, the presence of marine materials deep in the desert indicates a level of landscape knowledge, mobility, and interregional connection that is remarkable for this period. But before we imagine ancient people strolling casually through the same blistering, lifeless terrain visible today, we need to account for paleoclimate. The Atacama has not always been exactly as dry as it is now. Paleoclimate research, based on evidence such as ancient lake levels, pollen records, geological deposits, and isotopic analysis, indicates that during portions of the late Pleistocene and early Holocene, parts of the desert experienced periods of somewhat greater moisture. These were not lush green phases that transformed the Atacama into a garden, but even modest increases in precipitation could have supported more vegetation, maintained springs and small watercourses, and made travel across the interior significantly more feasible than it would be today. So the people at Quebrada Mani were probably not living under the exact conditions visible at the site in the 21st century. Their desert was still dry, still harsh, still demanding, but it may have been navigable in ways that the modern landscape is not. Even with that qualification, the discovery was enormously significant. The hyper-arid core of the Atacama had long been treated, reasonably, as a major barrier to early human movement in South America. Models of initial human dispersal tended to route early populations along the coast or through highland corridors, essentially going around the worst of the desert rather than through it. Quebrada Mani demonstrated that people were not merely skirting the edges. They were entering and using the deep interior of the Atacama remarkably early, within the first few thousand years of the human presence on the continent. That forced a reconsideration, not of whether the Atacama was difficult, it obviously was, but of how capable and how adaptable the earliest South American populations actually were. If 12,000-year-old miners and Ice Age desert travelers seem like enough to reconsider, wait, because the next discovery covers the surface of the desert itself, and it stretches for hundreds of kilometers. Scattered across the slopes, hillsides, and open surfaces of the Atacama are enormous images. Not paintings hidden inside caves, not small carvings on individual boulders. These are geoglyphs, figures created directly on the desert surface at a scale designed to be seen from a distance. One of the most spectacular concentrations is at Pintados, in the Tarapacá region of northern Chile. Here, across a long hillside, hundreds of individual figures and designs form one of the largest geoglyph complexes anywhere in South America. The images include stylized human figures, some with elaborate headdresses or radiating lines around their heads. There are llamas, birds, and other animals. There are geometric shapes, circles, lines, stepped patterns, and complex compositions whose meaning is no longer obvious. How were they made? The basic technique exploited a natural feature of the desert surface. In many parts of the Atacama, the ground is covered with a layer of dark stones, a surface sometimes called desert varnish or desert pavement, formed by long exposure to sun, wind, and chemical processes. Beneath this dark layer, the ground is lighter. By removing the dark surface stones, or by arranging rocks into specific patterns, or by combining both techniques, ancient people created high-contrast images visible from considerable distances. No paint was required, no elaborate technology, just an understanding of the landscape and a willingness to move a lot of rock. The temptation is to call these the Nazca lines of Chile, and some popular sources do exactly that. But the comparison, while understandable, obscures more than it reveals. The Nazca lines in southern Peru were created on flat desert plains and are generally best seen from directly above. The Atacama geoglyphs, by contrast, are frequently placed on hillsides and slopes, which means they are visible from the ground at a distance, not only from the air. Their archaeological context, cultural associations, and probable functions are different. And the most important difference is this. Researchers have connected many concentrations of Atacama geoglyphs with ancient llama caravan routes. For centuries before and during the period of Inca expansion, and possibly much earlier, llama caravans were the primary means of long-distance transport across the Andean world. Caravans carried goods between highland communities, coastal settlements, oases, mining areas, and agricultural zones. The routes they followed crossed some of the most inhospitable terrain in South America, including long stretches of open desert with minimal water and few landmarks. Archaeologists identify these ancient caravan trails through multiple lines of evidence. The trails themselves sometimes survive as faint paths worn into the desert surface. Along them, researchers find the remains of temporary camps, hearths, llama dung, broken pottery, food remains, and other artifacts associated with travelers. Water sources along the routes show evidence of repeated human use, And, critically, the geoglyphs tend to cluster along these corridors of movement. What does that suggest about their function? Several possibilities have been proposed, and they are not mutually exclusive. Some geoglyphs may have served as landmarks, helping caravan drivers navigate across featureless terrain. Others may have marked territorial boundaries, indicating which group controlled a particular stretch of trail or a particular water source. Some may have conveyed information about destinations, resources, or dangers ahead. And some almost certainly had sacred or ceremonial significance, connected to the rituals, beliefs, and spiritual practices associated with long and dangerous desert crossings. The honest answer is that we do not know exactly what most individual figures mean. The cultures that created them did not leave written explanations, and ethnographic analogies can only take us so far. What we can see is the extraordinary scale of the phenomenon. Ancient communities did not treat the desert as empty space to be endured. They filled it with visual information. They marked it, labeled it, decorated it, and made it legible. Travelers crossing the Atacama were not moving through a blank void. They were moving through a landscape that had been deliberately transformed into something that communicated. Hundreds of geoglyphs across hundreds of kilometers of desert. That is not the work of a few idle afternoons. It represents generations of collective effort by communities that understood the desert not as an obstacle, but as a territory to be organized and used. What would you see if you could stand in the middle of one of those ancient routes, surrounded by enormous figures on the hillsides above, with nothing but silence and heat and stone in every direction? Would it feel like a map? A warning? A prayer? Write your answer in the comments, because this is one of those questions that archaeology alone cannot fully answer. And now let us move from images carved into rock to something much stranger, something melted. Near the town of Pica, in the Tarapacá region of northern Chile, scientists found something that should not be easy to explain. Scattered across the desert surface were extensive deposits of silicate glass, not the smooth, rounded glass produced by volcanic activity, not industrial waste. This glass was twisted, folded, and deeply melted, with textures and chemical compositions suggesting exposure to extraordinarily high temperatures. The glass is real. That part is not debated. You can collect it, analyze it, measure its chemical composition, and examine its internal structure under a microscope. What is debated, and debated seriously, is how it got there. One research team, whose findings were published in a peer-reviewed journal, proposed that the glass formed during one or more exceptionally powerful airbursts, explosions produced when a cometary body enters Earth's atmosphere at high speed and detonates before reaching the ground. An airburst is not a theoretical curiosity. The most famous historical example is the 1908 Tunguska event in Siberia, where an incoming object, probably a small asteroid or comet fragment, exploded in the atmosphere with an energy estimated at 10 to 15 megatons, roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. The explosion flattened approximately 2,000 square kilometers of forest. No impact crater was ever found because the object never reached the ground. It disintegrated in the air, but the resulting shock wave and thermal pulse devastated the surface below. The researchers studying the Atacama glass argued that something similar, or possibly even more intense, could explain the deposits near Pica. They reported microscopic evidence they interpreted as consistent with extreme temperatures, unusual mineral phases, chemical signatures suggesting rapid melting and cooling, and, most controversially, possible traces of extraterrestrial material embedded in the glass. Their proposed date placed the event or events near the end of the Pleistocene, roughly 12,000 years ago, a period that coincides, perhaps not coincidentally, with a broader scientific debate about whether cosmic impacts or airbursts contributed to dramatic environmental changes at the end of the last ice age. If the comet hypothesis were confirmed, it would be a remarkable discovery. Evidence of a major cosmic airburst preserved in the deserts of South America, datable to the same general period as the earliest human inhabitants of the region. But other scientists have pushed back. A competing explanation proposes that the glass could have been produced by extraordinarily intense fires involving ancient wetlands and vegetation. This might sound counterintuitive in one of the driest places on Earth, but remember what we discussed earlier about paleoclimate. During parts of the late Pleistocene and early Holocene, Some areas of the Atacama supported more vegetation than they do today. Wetland environments, fed by springs or higher water tables, could have accumulated substantial organic material over time. If those deposits dried out and ignited, whether through lightning, human activity, or other natural causes, the resulting fires could potentially have been intense enough to melt surface minerals into glass. This is not a casual dismissal. Researchers advocating for the fire hypothesis point to specific chemical and mineralogical features of the glass that they argue are more consistent with prolonged surface burning than with the instantaneous, extreme temperatures of a cosmic airburst. They note that similar glasses have been produced in other environments by large-scale fires without any extraterrestrial involvement. So where does the debate stand? Neither side has definitively closed the case. The glass itself preserves evidence of extreme heat, but distinguishing between the thermal signature of a cosmic airburst and the thermal signature of an exceptionally intense surface fire thousands of years after the fact is genuinely difficult. The chemical and mineralogical clues can be interpreted in more than one way. The possible traces of extraterrestrial material reported by the airburst team have been questioned, and the fire hypothesis, while plausible, has its own unresolved questions about whether vegetation-fueled fires could realistically produce the specific temperatures and glass compositions observed. This is one of those cases where the most honest thing a narrator can say is, "We do not know yet. The glass is real. The extreme heating event that produced it is real. The mechanism is still being argued over by qualified scientists with access to the same samples. And that is precisely what makes it fascinating. It is not a mystery manufactured by speculation. It is a mystery manufactured by the physical evidence itself." If you are the kind of person who thinks real, unresolved scientific debates are more interesting than easy answers, this is the channel for you. Subscribe, because the Atacama is far from the only place where the physical evidence refuses to fit neatly into a single explanation. We keep finding more. And speaking of things that become clear only when you change your perspective, let us go higher, much higher. In the Camarones Basin and surrounding areas of northern Chile, researchers studying satellite imagery noticed something peculiar. Across large stretches of barren, rocky terrain, there were stone alignments. Walls, or more accurately, low lines of stacked rocks, extending across the landscape in patterns that were difficult to understand from ground level. Some of these alignments stretched for hundreds of meters. Individually, a line of rocks in the desert does not look like much, but from above, from the altitude of a satellite or an aircraft, the design became unmistakable. The stone lines converged. They formed long, funnel-shaped systems, with wide openings at one end that gradually narrowed toward a confined area at the other. The architecture, if you can call it that, was clearly designed to channel something moving across the landscape into a progressively tighter space. These are hunting structures. Researchers call them chaku, a Quechua-derived term, and the basic principle behind them is elegantly simple and brutally effective. A group of hunters, working together, would drive animals, likely vicuñas, guanacos, or other camelids, into the wide end of the funnel. The low stone walls did not need to be tall enough to physically block a panicking animal. They only needed to be visible enough to guide it. Animals fleeing from noise, movement, or human presence would naturally follow the path of least resistance, running along the walls rather than over them. As the funnel narrowed, the animals were compressed into a smaller and smaller space, eventually reaching a confined area where hunters could kill or capture them with far less effort and far less risk than an open chase across broken terrain. One remote sensing study using satellite imagery identified 76 of these structures in a defined study area. Surveys of the broader region have documented more than 100 possible examples, though not all have been confirmed by ground-level archaeological investigation. How do archaeologists determine that these are intentional constructions and not natural rock formations? Several lines of evidence converge. The alignments follow consistent geometric patterns, particularly the funnel or V shape, that do not occur naturally in the local geology. The stones show evidence of having been deliberately placed or stacked rather than deposited by erosion or gravity. Artifact distributions around the structures, including stone tools, animal bones, and processing debris, are consistent with hunting and butchering activity. And the spatial relationship between the structures and the surrounding landscape makes functional sense. They are positioned in relation to natural animal movement corridors, water sources, and terrain features in ways that maximize their effectiveness as traps. The comparison that researchers most often reach for is the desert kites of the Middle East. In the deserts of Jordan, Syria, Saudi Arabia, and neighboring countries, archaeologists have documented thousands of large stone hunting structures with a remarkably similar design principle: long walls converging toward enclosed spaces. Some Middle Eastern desert kites are enormous, with walls stretching for kilometers. They were used to hunt gazelles, onagers, and other herd animals, and they represent one of the most impressive examples of prehistoric landscape engineering anywhere in the world. The Atacama structures are not historically connected to the Middle Eastern kites. There is no cultural link, no shared ancestry, no diffusion of ideas across the Atlantic. The resemblance is a case of convergent engineering. Two different human populations, separated by thousands of kilometers and thousands of years, facing a similar problem, hunting fast-moving herd animals across open, arid terrain, arrived at essentially the same solution. Why does that matter? Because it tells us something important about the people who built them. Constructing a funnel-shaped hunting system that stretches across hundreds of meters of desert is not something one person does on a slow afternoon. It requires coordinated labor. Someone has to plan the layout. Groups of people have to collect and place the stones. The design has to account for local topography, animal behavior, wind patterns, and the positions of water sources. And the hunt itself requires coordination. Drivers who push the animals, flankers who prevent them from escaping sideways, and killers or capturers waiting at the narrow end. This is collective, planned landscape modification in one of the harshest environments on Earth. The people who built and used these structures were not passively enduring the desert. They were actively engineering it to serve their needs. They were reshaping kilometers of terrain to make the business of survival more predictable and more efficient. And some of these structures are so large that they remained invisible to modern researchers until satellite imagery made them visible. They were always there, we just were not high enough to see them. There is a certain irony in that. We had to go to space to understand what people on the ground were doing thousands of years ago. Now, from enormous structures that required a change in perspective, let us move to something very small. Something that, for a while, seemed to require a change in everything we thought we knew about biology. In 2003, a tiny skeleton was reportedly found in an abandoned town called La Noria in the Atacama region of Chile. The specimen measured approximately 15 centimeters, about 6 inches, roughly the length of a ballpoint pen. It had an elongated conical skull, an apparently unusual number of ribs, and a body that, at first glance, looked disturbingly unlike a normal human being. Photographs of the specimen spread rapidly. It acquired a name, Ata, and a reputation. In UFO and paranormal communities, it was seized upon as possible evidence of extraterrestrial life or an unknown humanoid species. A documentary filmmaker featured it prominently in a film about unidentified aerial phenomena. The story made international headlines. The circumstances of the specimen's recovery created immediate problems for any serious scientific analysis. Ata was not excavated by archaeologists under controlled conditions. It was reportedly found by a local person, passed through private hands, and eventually ended up in a private collection in Spain. There was no documented excavation context, no stratigraphic information, no associated artifacts, no clear provenance chain. For an object that was about to become one of the most controversial biological specimens in the world, the lack of basic archaeological documentation was a serious deficit. But the specimen itself was real, and it was eventually subjected to rigorous scientific analysis. In 2018, a team of researchers published a whole genome study of Ata in the journal Genome Research. The DNA analysis was thorough, and the results were unambiguous on the most basic question. Ata was human, completely, unequivocally human. The genome showed no evidence of non-human ancestry of any kind. The individual was genetically female, and the ancestry was consistent with a Chilean origin, specifically with the mixed indigenous and European heritage found in modern Chilean populations. The presence of European ancestry suggested that the remains were not thousands of years old, but more likely dated to the historical period, possibly within the last few centuries, though no precise date was established. So much for extraterrestrials. But the story did not end there, because the genuine scientific questions about Ata were, in their own way, more interesting than the sensational claims. The research team identified several genetic variants in genes associated with skeletal development. They proposed that these mutations could help explain some of the specimen's unusual features: the abnormal skull shape, the apparently unusual rib count, and other skeletal anomalies. Some of the variants were in genes known to be involved in conditions such as dwarfism and skeletal dysplasia. However, that genetic interpretation was subsequently questioned by other researchers. Critics pointed out that some of the identified variants were relatively common in the general population and might not be pathogenic at all. Others noted that the sheer number of supposedly causative mutations identified in a single individual strained credibility. The genetics, in other words, were suggestive but not fully convincing as an explanation for the specimen's appearance. A separate and equally important issue involved the basic question of what Ata actually was in developmental terms. The original study noted features that could be interpreted as consistent with a child or even a postnatal individual, which was part of what made the specimen seem so mysterious: a 15-centimeter being that appeared to have lived after birth. But subsequent anatomical assessments argued strongly that the remains were those of a human fetus, not a miniature adult. The skeletal features that seemed anomalous could be explained, at least in part, by premature death and abnormal fetal development. The unusual bone counts, the skull shape, and the overall proportions were more consistent with a fetus affected by severe developmental abnormalities than with a tiny person who had survived to childhood. This matters because it removes much of the supposed mystery. A human fetus with significant genetic or developmental abnormalities is a tragedy, but it is not biologically inexplicable. Such cases, while rare, are documented in the medical literature. The unusual combination of features in Ata may be extreme, but it falls within the range of known human developmental variation, broadly understood. What remains genuinely unresolved is more modest but still scientifically interesting. Exactly which genetic factors contributed to this specific combination of abnormalities? Can we determine that with confidence from a specimen whose archaeological context was so poorly documented? And what can researchers legitimately conclude when the provenance of the remains is uncertain and the circumstances of recovery are murky? There is also an ethical dimension that cannot be ignored. Ata represents human remains from Chile. Regardless of their age, the specimen is subject to questions about how it was collected, how it was exported from Chile, who has the right to possess and study it, and whether the communities from which it may have originated were consulted or involved. Scientists and bioethicists have raised pointed questions about the entire chain of custody. Chile has laws governing the treatment and export of archaeological and human remains. The fact that Ata ended up in a private collection in Spain and was subsequently studied by international research teams without clear authorization from Chilean authorities or engagement with Chilean communities created significant ethical problems. These are not abstract concerns. The study of human remains, particularly those originating from indigenous or historically marginalized communities, is increasingly governed by ethical frameworks that require informed consent, community engagement, and respect for cultural sovereignty. The Ata case became, among other things, a cautionary example of what can go wrong when sensational claims outrun both scientific rigor and ethical responsibility. The real lesson of Ata is not that aliens visited the Atacama. The DNA ruled that out decisively. The real lesson is that even a single set of unusual human remains can generate a cascade of questions about genetics, development, archaeological method, scientific ethics, and the responsibilities of researchers who find themselves holding something they do not fully understand. If you found this story valuable, share it with someone who still thinks Ata is unexplained. The explanation is there. It is just more complicated and more human than the headlines ever suggested. Now step back for a moment and consider what we have seen. A 12,000-year-old mine where coastal hunter-gatherers extracted red pigment with specialized tools century after century. Evidence of human occupation in the hyper-arid heart of the desert almost 13,000 years ago, complete with marine shells carried from the distant coast. Hundreds of enormous geoglyphs transforming barren hillsides into a navigational and symbolic landscape for ancient caravan travelers. Fields of melted glass whose formation mechanism is still genuinely debated between cosmic airbursts and extraordinarily intense surface fires. Hunting systems so large they were invisible until satellites revealed their geometry from orbit. and a tiny skeleton that generated worldwide headlines about aliens before DNA confirmed it was simply, and tragically, a human fetus with severe developmental abnormalities. Every one of these discoveries has something in common. Each one challenged an assumption. The assumption that early coastal populations were too simple to organize mining. The assumption that the deep Atacama was uninhabitable during the Ice Age. The assumption that the desert surface was empty and meaningless. The assumption that extreme heat events in the desert must have a single obvious cause. The assumption that prehistoric desert dwellers hunted only as individuals or small groups. And the assumption that something small and strange must be something other than human. The Atacama does this to assumptions. It destroys them slowly, the same way it destroys everything else, with time, silence, and an absolute refusal to behave the way you expected. There is a deeper point here that is worth sitting with. We have a tendency to treat deserts as absences, empty spaces between the places that matter. The Atacama, especially, gets described as the driest, the most barren, the most lifeless. And in terms of rainfall and visible biology, that is accurate. But in terms of the human record it preserves, the Atacama is one of the richest archaeological environments on the planet. Precisely because it destroys so little, it remembers almost everything. Wood that would rot in a century elsewhere survives for 12 millennia. Stone alignments that would be overgrown in a forest remain exposed and legible. Glass that would be buried under sediment in a wetter climate sits on the surface, waiting to be collected and argued over. The desert is not empty. It is an archive, and we have barely begun to read it. What would change if we stopped treating the Atacama as a dead zone and started treating it as one of the longest-running records of human ingenuity, adaptation, and resilience on the continent? What else is out there, buried under the salt, scattered across the hillsides, or sitting in plain sight at a scale we can only see from orbit? Those are not rhetorical questions. They are research programs waiting to happen. And the answers, when they come, will probably be stranger than anything we have found so far. The Atacama has a habit of being stranger than anyone expects.